right, 3 and 2 and 1, and let's go. All right, cool kids. Some of you have had a chance to check some. Some of you have hopefully found Abby. Here we go. Some of you guys have had a chance to check some, but let's go ahead and come all back together. I basically wanted to make sure that you at least had the main idea. The section in number 12, if you guys have matched up, that would show that you understood to make little triangles, to think about the ratios, and HPrecalc, but obviously homework got a little bit more involved in that. Let me zoom in just a little bit. I also didn't want you guys to have to spend forever on this page, just in case someone did miss something. All right, so then, number 12, we have the following for sine, cosine, tangent, cosecant, secant, cotangent. With the first given information, you would have had to have found your root 5 from your 1 and your 2. So I think they gave you tangent, right? People who wrote the question, they gave you tangent, right? Don't say yes if I'm wrong. Tell me if I'm wrong. Oh, they didn't give you? Did they give you a triangle? Okay. Okay. So they gave you the opposite, they gave you the adjacent. You could steal for tangent and cotangent, you could flip it, but for the rest you had to find the third side with Pythagorean, hence the root 5, plug and chug and rationalize. For the second one, I gave you the 3 and the 6, which is ironically, the same ratio as 1 and 2, so even after you find the hypotenuse, you find it to be 3 root 5. The numbers are different than the other one, but guys, what ended up happening with all of the trig? Because the trig is not based on the size of the triangle, it's based on the ratios and the proportions, right? So since these two, what's in geometry, what's the names of two triangles that have sides that are proportional, whose ratios are equal? What's that mean? I don't think I've heard it yet. You guys are just quiet. No. Not congruent. So it has to be the same size. This one's smaller, right? But what's this?
Supplementary.
No, but close. It does have an S.
Similar.
Similar.
Was that right?
Similar.
Are you kidding me?
Similar shapes have proportional sides, meaning 1 to 2 are the 2 legs, 3 to 6 are the 2 legs. As soon as you saw that, if you guys figured out, hey, it's the same thing as 1/2 or 1 to 2, you could have just stolen all the trig and not done any of the work. Geometry's nice if you catch it. Okay, shoop, 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 shoop. Number 24, our final answer is root 3. How come? Because it's ultimately a 30-60 triangle. If you figure out the 1 and the 2, you should get the root 3. But the other way, not the other way, sorry, the other part they were asking, I think, was to convert to degrees. Pi over 3, 1/3 of a calzone, 1/3 of 180 is 60. And that wasn't just root 3 you were trying to find, I apologize. You were trying to find opposite over adjacent or tangent, which ended up reducing to be root 3. Number 38. You guys still remembering where degrees, minutes, seconds are in your calculator?
Yeah.
Where? Second, is in the angle menu, second apps, good. Second apps, but you have to be in what mode? Degree mode. Make sure, double check. But yeah, you have to be in degree mode, and you go ahead and plug and chug. Guys, is this chapter going to be a little rough because we had those angular speed, linear speed, we had those ones where angles had to be in radians? Are you going to have to be careful with your modes on the test? Yes. Okay. So, wait, how'd you guys do secant in the calculator? There's no secant button.
1 over cosine.
Good. Don't you dare do second cosine. Don't do cosine to the -1. It's not going to equal the same thing. You can try it. That's cosine inverse. If you tried that with this, it's actually going to say it does not exist. Because cosine inverse says, give me a ratio, I'll give you an angle. So if you plug in 56, cosine can never equal 56. Your calculator will freak out. Do 1 divided by cosine, what the formula says. Number 54. Do you guys have fun plugging and chugging? Little baby puzzles. You can plug in 1 minus sine squared, or you can plug in for sine squared 1 minus cosine squared. That would have worked also. That would have worked also. But this one, they wanted you to keep the sine. They wanted you to keep the sine squared, and so hence why they plugged in for the cosine squared and simplified. If you plugged in for this one instead, you would have had a little bit of issues. Number 70, it's just opposite over adjacent, is what we have to think about. Looking at our triangle, we knew the angle, we knew the adjacent, solve. 137.5 I would have liked 3 decimal places, you guys know that. And I think that's our last even. So, questions? Odds or evens? Patricia? 87. Cool. D, same one?
No.
Oh, go ahead.
55.
Okay, 55 and 87, right?
I just think I did overall different problems than.
Uh-oh. Why don't you check the assignment with someone nearby, and then can you just check with Caroline, see if they kind of match up, like if she did a 5 and you did a 4, if she did a 10 and you did a 12, see if they kind of match up, and then I'm going to come back and look at it, and as long as they kind of match up, meaning that you've done the same practice I wanted you to do, I'll sign off on it so that the TAs know. But if there's some you're missing, I'll be like, you maybe better do these problems real quick, okay? So go ahead and check really quickly as to how much they match up. No.
67.
Okay. So I have 55, 67, and 87. Patricia has 87, right? I think that's right. Okay. Number 55. Let's get rid of the evens because we already checked that. And the book is right here. Okay, starting with number 55. Oh, that was a fun one. I like it. Hey, cool kids. For those of you who don't like homework, this one's good practice. How would you have done this? Question. Which side? Hey, a lot of you guys didn't do homework. A lot of my ones that should be able to. How? And those of you that did try, some of you got it and some of you got stuck. What do you think? Which side do you think we should keep fixed, remember?
The right side.
I would do the right too, I think. And the reason why, we'll talk more when they get harder. Ooh, when they get harder, something called T-proofs. That's really fun. Tiny puzzles with trig. When they get harder, we want to pick the fixed one to be the simplest one. This one has denominators that are different and addition. There's all sorts of stuff we can do on the left. On the right, we can make it 1 over sine and 1 over cosine. So we're going to keep the right hand fixed, which means we're going to play with the left hand. What's something we could do on the left? Make a tangent, make a cotangent. Bad idea, it doesn't match that. But what could we do?
Multiply by the denominator.
Hey, the common denominators, huh? And whenever we get common denominators, we can multiply them by different quantities as long as we make sure that we're multiplying really in essence by 1. We're not messing things up. As far as what they equal, we're just changing how it looks. So what happens when, oh, we need a cosine on this one. What happens to this one when I multiply? You can say sine theta squared, but what's the notation for that? Good, sine squared of theta. What's this one going to become? And why am I putting them together? They have the same, I'm putting them together because they have the same denominator, right? Common denominator? Good. Keeping this side fixed, hoping I will be able to show why it is what it is, but someone already gave me the clue. What's sine squared plus cosine squared? Oh. Wait.
That's the same thing as the other side.
Yeah, so how do I show it?
1 over.
Couldn't I, since it's just multiplied, couldn't I technically just multiply 2 little fractions?
Yeah.
Cool. So I just equals 1, so I can say, oh, since it's just multiplication, it means the same thing whether I put it together or apart. So therefore I can say, okay, cool. Now, maybe a middle schooler couldn't figure this one out, but anybody who knows their trig properties are like, oh yeah, good job, you did it. Thus it has been proven. Quod error demonstrabum. Latin for thus it has been proven, abbreviated QED. Watch the Pirates movie, the second one? Johnny Depp before they, I don't even know, I haven't watched the most recent one. The one where he was in the desert and then they were coming after him. Was he dead? And there was like all the dirt and there was like all the whatever.
That's the third one.
Right when they come back, he says QED. Anyway,
That's the third one.
he was speaking Latin. For thus it has been proven as to why we made it. Yeah.
We're gonna get flashcards for some of these properties on the test.
Okay. Now we have number. That's for Monday. That's for Monday. Number 67. I mentioned it quickly yesterday. I'll remind us more today. It's on the calendar too. 67.
Yeah.
67. Empire State Building, and there was one more. 87, right, Patricia? Next page.
Miss, your test question's not gonna be into this grading period.
Right.
Okay.
It's on the next page? Where's 87? Oh, there he is. Alright, cool kids. Empire State Building. Draw me a picture. What'd you guys do? Triangle, good. I have ground, I have building, I have person, I think. Is that right? Yeah, I have person, I have building, I have ground. Not leaning Tower of Pisa yet, so we'll just pretend you straight it down, even though my triangle doesn't quite look like it, but that's okay. What can I label? If I was to mark this as an angle, be precise, what can I mark? Okay, so 82. What else can I mark? Use the triangle. What? Adjacent. Thanks, Shaky. So the adjacent is 45. What else can I measure?
The 1, 2, 3 on the opposite.
Opposite?
Nice job, Janelle. So X plus 1, 2, 3.
So where am I looking? Double check. So the top floor is the 86th floor, but then the building keeps going higher, because you can't always get to the very tippy top of the building. Then there's the ones, is it the Empire State Building? No. Yes? We're just, they built up higher to try to make it taller than all the other cities, or all the other buildings at the time. Same thing with the big old one in LA, it's called, oh, what's that new building in LA? My friend's dad is a building inspector on it. No, the new one, that's like the tallest one, it's taller than the. What's what it's called?
Trump Tower.
No, it's something towers. That was much fun. The 101, no, it's like a number or something. Anyway, there's some building in LA and they wanted to make it tall, so they put something on top just to. Anyway.
You call it a Dweck Tower.
We just wasted money.
Anyway.
Building.
Empire State Building is at the top of it, and it's like, hey, let's put something else just so we can say we're taller. Yeah, I know, it's a thing. Anyway, coming back. I think it was Empire State Building, so they were giving it as I went on tour. Anyway, what's the approximate height of the building?
So we're doing
86 times 10.
What do you call that, X?
Can we do sine?
Times 10, why would you do 10? Don't do sine.
Okay, we solve for
I don't
X.
care about that. Yeah, but you're not gonna use sine.
Oh wait, that's 10.
Yeah, so you're gonna use tangent, right?
Opposite over
Okay. So you're gonna tangent of 82 is equal to x over 45, and as you guys get used to these, you could have just said x is equal to 45 times tan of 82. It's gonna multiply over.
Plus 1.
Yeah.
Degree mode. But what's the height of the building?
That plus 1.
That plus 123. So I could say the height of the building is equal to x plus 123. Someone plug and chug that to their calculator if you have not yet already. But there's also the question, what's the distance between you and your friend? We'll get to that in a second. PS 1. This one is 450? No point? 119?
191.
Ah. But someone said 2. Is it round?
Round.
Ah. And then we were talking about meters, I believe, true? So that's the whole thing. X plus 123 is 443.192. But they also ask, how far are you from your friend? So you solve for hypotenuse. Could you use the approximate decimal And your tangent, not tangent, I guess, sine. Yes. We don't want to use an approximate when we can use an exact. So don't say there's two different ways of solving it. Only use the one exact one. The one exact one and say, let's use that 45. Hence, what trig function are we going to use? Cosine. Ooh, guys, how do you solve for that? Just, yeah, undo the division, even if it doesn't seem to make sense. Multiply the y and then, oh, okay, divide the cosine. Answer in the back of the book, you guys know what to do, call out in meters and you're done. Okay, that's 67. The picture was a little weird because the top floor, this was not a level building, it has that higher on the top.
Oh.
And I think what it was is that two guys were building buildings at the exact same time, and then the one, they put the pyre on to try to beat the other one, but it was like a hidden thing, so they unveiled them like, ah, my wins. Anyway, 87. Look into the history of the 87. Complete the table. How do we complete a table? Plug and shove. Guys, could you make a y1 sine and a y2 cosine? And could you, what would you do to your table setup? Remember, we can make the table do what we want. You could plug in every single one, sure, go have fun. Or you could make that y1, that y2. How would you make your table setup? Second window? Intervals of 18. Which one changes the intervals? Have a little delta. Nope.
No.
Start at 0, but then the little delta, delta step or delta second window. Tables start at 0, and then a little delta table. Remember the Greek letter delta? We talked about the little triangle. Make it go by 18s. And then you're going to your y1 sine, y2 cosine, second graph. Don't go to your list. You have to type that in yourself. Go to your table, second graph. It'll generate it for you. Just make sure you're underneath. Then it says, describe the behavior of the sine function for thetas between 0 and 90. What is sine doing between 0 and 90?
Wow.
Should be going up. You may see sine increasing. I think its values go up. I mean, how do they go up? But your calculator should show that. Yeah? And then what's cosine doing at the same time? If you think about your unit circle, sine's going from 0 to 1/2 to root 2 over 2 to root 3 over 2 to 1. Cosine's going from root 3 over 2, from 1 to root 3 over 2 to root 2 over 2 to 1/2 to 0. Think of my table. One goes up, the other goes down, right? Use the definition of sine and cosine to explain the results of parts B and C. I would, if I were you, here's looking at the first quadrant, right? I would think about a triangle. And as you fit in an inscribed triangle, what's going on to the adjacents as the triangle gets closer and closer to 90? The adjacents are getting smaller. Adjacent, who's adjacent? Cosine. And then what's getting bigger? Opposites, which are sine. So it just makes sense from the triangles that are fitting. Okay, with that, I think that finishes 87. Does that make sense? Okay. Good homework questions. Why is this here? We're starting this today. We're starting section 4.4. You guys can get your notes out and ready. But what have we been practicing the last few days? Unit circle. How come? I've told you, and Eileen has told you, you need it in. But also, it's on the SAT. But also, it's on math placement exams, if that's still a thing by the time you guys are applying to college. But also, it's in any sort of, not statistics per se, but any physics class. Or any calculus class, or any business calculus class that you might need to take. Or if a math placement test sends you that. Take high school math again, if it's still a thing when you get to college. They're trying to take it out and basically be like, we're just going to throw you into hard math classes and see if you pass or fail.
I like throwing.
It used to be like, we'll give you a placement test, so we don't want you in those classes, passing and failing until you're ready to be in those classes. Now, like, too bad, so sad, we're too impacted. Even though you got time and money to teach you math again, you should have learned the first time. I know it's a struggle, but our colleges are impacted, they don't have enough room or space or money to pay teachers. Maybe they just don't feel as much.
She treats us like no, Mrs. Hope. She's like, all right, go figure it out. And she's just like,
Okay, we're gonna do more with trig today. However, the unit circle, even though you don't have to be fast, well, you don't have to be faster than anyone else. You still want to be fast at the unit circle. Even though you don't have to be faster than everyone else, you do still want to be fast at the unit circle. So maybe you guys get this down, just so that we have 4-4 started, but then we're going to go review the unit circle. I'll tell you really quickly about the quiz on Monday on the unit circle. Hey guys, anybody absent today?
not my group.
Was anyone absent yesterday? You know, it's random, I didn't take roll yesterday. So if you guys are here, you would have told me if you weren't. Okay, absent. Go team. It's okay.
Yeah.
Everyone said it has the nuts.
Why is the sign Is it just like for problem solving or is it?
Radians happen more naturally in the real world than physics and different applications. And if you don't have an idea about sine, cosine, tangents, etc., radians, you can't even approximate. So it's kind of trying to picture it as math.
It's called the average.
Because you're so used to degrees that if I were to ask you about radians, you'll be like, what?
Yeah.
And so, trying to help you to mental math.
Do we look like twins?
Yeah, she knows there's no
Because she already knows.
Am I left side?
The lowest you can get is you get 1 point just for being you.
Yeah, you get like
I think the bonus is a multiple choice too. Alright, okay, thank you. I want you guys right now, pencil in your notes. Well, I guess not pencil. Hold on, just grab out your workspace. I just want you to get paper out. You can use your pencil. I don't want to make you put your pencil away. That'd be nice. So like hide it in your notes. We're getting back to our notes in just 1 second. Pencil. Why don't you do some walking?
What's this in the back?
All the pink pads are gone. That's what's missing.
I didn't know that.
It's Twix. It's Snickers. Okay. In your workspace, no one is allowed to vote, aka no one is allowed to say I have an answer. Until I've counted 15, what am I trying to say? I've counted 15 seconds, and then I've gone 5, 4, 3, 2, 1, go. I go, you're allowed to raise your hand. So everybody's going to write down the unit circle problem that I'm going to give them. You're going to have 15 seconds to do whatever you want, to write a quadrant, to draw a triangle, to change to degrees. Some of you have different ways of doing this. But you need to find a way that works for you. Maybe the first problem or two, you're just going to do your cheater chart and then have it for the rest of the time. half. But can I show you one more thing before we start? George Corey. It's been a while, but finally figured out a way the unit circle works for him. This is the first quadrant. 0, 30, 45, 60, 90. Okay? 0, pi over 6, pi over 4, pi over 3, pi over 2. Okay? You guys have your first quadrants? This should be you're probably using your left hand, right? With left hand you have 0. I'm just showing you my perspective. I'm using my right so that it's for you guys, you're 0. This is for you guys. But if I were you, I would use my left hand. Let's not do that. It's kind of awkward though. Okay. So, ready?
Yes.
On the fingers, you can find the sines and cosines, and here's how. On your fingers, you can find sines and cosines, and here's how. Ready? Didn't we just say that sine decreases and cosine increases?
Yes.
Sine, no, I said that backwards. Sorry, sine increases, cosine decreases. Okay, ready? Let me just do an easy one. If I was to put down 45, aka pi over 4, do you see that there's a 2 on one side and a 2 on another?
Yeah.
Take the square roots of both and put them over 2. Cosine is root 2 over 2. Sine is root 2 over 2. What happens if you go down to pi over 6? Cosine is root 3 over 2. Sine is 1/2.
Oh.
Cosine's on top, sine's on bottom. Cosine is root 3 over 2. Sine is 1/2. Take the square roots of both and then you put them over 2. So root 2 over 2, root 2 over 2, root 3 over 2, 1/2, because root 1 is 1. Go here, root 4 over 2. What's root 4? 2. 2 over 2 is just 1. Cosine is 1, sine is missing, it's 0. Come up to pi over 3. Cosine's 1/2, sine is root 3 over 2. Come up to 90. Cosine is missing, sine is 1.
Wait, did he just think of that? Or
No, that's not on mine. He kept on trying to find new ways. There are tons of different ways of memorizing. This is one that works for him. Now, could you go second quadrant? But you have to think about negatives and positives. Could you go third quadrant? Could you go fourth quadrant? Just you have to figure out a system that works for you. But that's first quadrant.
I like the cheater.
I can't remember.
But I gotta remember. What?
You write down the
He was like, cover it. Okay, here we go. I'm going to give you one. You have 15 seconds, and I'm going to count down 5, 4, 3, 2, 1, go. When I say go, you're allowed to raise your hand if you think you have an answer. Okay. And to be honest, you could probably do the cheater chart and just miss the first one. Go ahead and write down cosine of 7 pi over 4. Go. Sorry, just when I finish writing. Five, 4, 3, 2, 1, go. First one I saw, Brian.
Is it 45?
That's not the answer, but you're at the right place, but I can't take that as an answer for sure. Yes. So you're right, you were at a 45, but I said cosine of. Cosine of. So it's a 45, Patricia, what quadrant were you in? Fourth quadrant, 7 pi over 4. Think of our calzones. We had all 4 and 3 more. We were over in the fourth quadrant. Square root of 2 over 2. It was positive. All students take calculus. Cosine used to be positive, or you can think adjacent, the x's are positive. Okay, ready? Write down another one. Pause. Who all got that right? Let me see. Square root of 2 over 2. Nice. Who at least got the right number, just the wrong sign? Every 45, guys, over 4 would have been this one. So you would have known it was a square root of 2 over 2. So you have to figure out the sign. Okay, write down sine of 2 pi over 3. Five, 4, 3, 2, 1. Not until I say go. Put your hands down.
Dang it.
5, 4, 3, 2, 1, go. Okay.
1/2.
Melanie. Yeah.
Root 3 over 2.
Root 3 over 2. Dang it. Oh, it was it was, yeah. Pi over 3 would have been the 60. Square root of 3 over 2. Goes in what quadrant? 2 pi over 3. Second quadrant. Sign is positive, so it's okay.
So then you would just say the y value, you wouldn't have to say the x value too?
Right, because the x value is cosine. The y value is sine. Does that make sense?
Yeah.
So another one. What if I was to ask you for sine of 7 pi over 6? If you think about it, you should be able to get this one really fast. Hands down.
And you already got your candy, Jack. Like you
5,
did.
4, 3, 2, 1, go.
I know, I went.
Negative 1 over 2.
Alright, you guys got it right. Let me see. Good. Okay. Where is 7 pi over 6? What quadrant? Wait, think. Does that make sense? We have all 6 pieces and one more.